Right, so this is video number 3 for section 7.3. Okay, and the reason I've split this up is because some of you asked for shorter videos, and the only way I can do shorter videos is to do more of them for each section, because I can't shorten the amount of information in the section. So I just shorten each video but do more of them. So here is where we're going to see graphically what a logarithmic function looks like, as well as compare it to the graph of an exponential function, and you'll be able to see that they are inverses. Okay, so the graph at the bottom here, and I'll slide it up in just a second, it shows y equals 10 to the x. We learned how to graph those in sections 7.1 and 7.2. But they also graphed in blue the inverse of that, which is y equals log of x. Okay. If you want to know where it came from, you could plot some points. You could go to your graphing calculator, and I want to show you how to do both of those. So when I go to y equals and I start out, I'm going to do the exponential function in red so that it's just like the one in your notes. That's equal to 10 to the x. And then the inverse of that, y equals log. Your log button is on the left-hand side right next to the 7. So you're going to do the log of x. We don't need a subscript because this is a base 10. See, notice in your exponent form, your base is a 10. So the base for your logarithm is a 10, which you don't have to type. So now let's graph it. Okay, and something you need to know is, well, let me adjust my screen so it looks a little bit more like the one in your notes. Remember, you can adjust your window, and I'm going to tell it the minimum x will be -2, because that's what your book has, and the maximum will go out to 10. Your y minimum will go down to -2 there as well, and out to 10, and then regraph. It's going to take just a second. What I want you to know is that this blue graph, it doesn't just end here. It has to do with the resolution and stuff in the calculator. You just can't see it, but for whatever reason it looks like it stops, but it doesn't. It continues downward forever, but it never crosses over the y-axis. Okay, remember, for these red ones, our exponential functions, the x-axis is an asymptote. Well, for logarithmic functions, your y-axis is an asymptote. And so now remember, if we were to graph the line y equals x, let's go down and make it a different color. We'll make it green. Y equals x, and graph it. If I were to fold my paper on that line, the red graph of the exponential function would be directly on top of the logarithmic function that's in blue. Okay, remember that's how inverse functions work. We talked about that in section 6.7. So here you've got it. Okay, and it gives you all that information here in the top part of the notes. So if you want to go back and recopy all that, you can. If you need to paraphrase it, that's fine. But now we're going to look at actually graphing a couple of logarithmic functions. So now I'm going to give you a couple of options for how to graph these. And some of you will like one way, some of you will like the other way. What I'm going to suggest you do is to start out changing to exponent form. So when I change this problem, y equals log base 3 of x, when I change it to exponent form, it's going to be x equals 3 to the y. Now, what you can do is you can go ahead and make a table at this point. If you're going to make a table at this point, you have to decide, you know, do I pick values for x or do I pick values for y? And because x is by itself, I want to be able to solve for x. So I'm going to pick values for y. I'm going to do a couple of negative, 0, and a couple of positive. And now plug them in, just like we did with the exponential functions from earlier in the chapter. So when I have 3 to the negative 2, that's 1 over 3 squared, gives me 1 over 9. When I do 3 to the negative 1, I get 1 over 3 to the first, which is just 1/3. But now when I have 3 to the 0 power, I get 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. And my graph is obviously not big enough to show that last ordered pair. So we're just going to graph what will fit over here. So 1/9 over 1/9, and I'm going to go down 2. 1/3, negative 1, 1 0, 3 1, and 9 2. Okay, and I still ran out of room a little bit. If I connect these, this is what it'll look like. Okay, and remember, your y-axis is an asymptote. The graph doesn't actually touch it. Mine does because I don't graph perfectly. It's a sketch, it's close. That's about as good as I can do. Okay, so this is one way, and I think it's probably the easiest way to graph a logarithmic function. But in the next one, I'll give you another option. Okay. Oh, and I almost forgot. Got to go back up here. They didn't just ask me to graph it. They also want to know what is the domain and range, as well as what is the y-intercept and the asymptote. So to figure out your domain for this one, I want to know how far left and right this graph goes, because the domain deals with your x values and x goes left and right. My graph goes almost to 0 And because it goes almost to 0, but not all the way there, it gets a parenthesis, and then it will go all the way to infinity, and those always get parentheses. Your range, we want to look at our y values, how low and how high it goes. So this one, it will eventually go down as low as negative infinity and as high as positive infinity. Now your y-intercept, it doesn't have one because it never touches the y-axis. Remember, your y-axis is your asymptote. Okay, and your equation, if you're writing an equation for your asymptote, it would be x equals 0. So now, here's the guided question. And I know I told you I was going to tell you another way. I think I'm going to leave it at that and just show you the one way. If you don't understand that, when you come to class next time, let me know and I'll show you the other way. But it's a lot longer and a lot more involved. So unless you really need another way, we're just going to leave it alone. Okay, so why don't you go ahead and try the guided question. Start out changing this logarithm into exponent form. Make a table, plot some points, and then we'll talk about the domain, range, y-intercept, and the asymptotes in a minute. And I can't plot the point 16.2. I can't even get close, so we're going to kind of estimate that part of the graph. And then over here, I'm getting closer and closer and closer to that y-axis. Here's what my graph of y equals log base 4 of x looks like. So my domain, again, is going to be 0 to infinity. The range, negative infinity to infinity. The y-intercept, it doesn't have one. And your asymptote, again, is your y-axis. And the equation of that is x equals 0. So now we're going to talk about shifting a logarithmic function up or down, left or right, talk about a stretch and a compression, as well as a reflection over the x-axis. All the same guidelines for a stretch, compression, reflection, shift, all of that we talked about for every other function all year long, that we just talked about for the exponential functions, it all still applies to these graphs. So here we go. Okay, this box starts out talking about, here's your parent function. Again, the base for your logarithm has to be positive and it cannot be 1. If there's a number in front of your logarithm, if the absolute value of that number is bigger than 1, it stretches it up a little bit taller. If that number in front, if the absolute value of it is between 0 and 1, it kind of squishes it down, flattens it out a little bit. It's called a compression. And then if your A is negative, that's the one that's going to flip it upside down. Okay, and just like with all of our other functions, if it is inside with the x, it's going to go left or right, and we do the opposite. If it comes after all of that, it's going to shift up or down, and you're going to do the same as the sign. Okay, and so here they put it all together for you with the A out in front. So now, for problem 5, what they want us to do is to graph y equals log base 4 of x minus 3 plus 4, and how does that compare to the graph of the parent function? So first you got to know what the parent function is. Well, basically you're just going to take off all of that stuff, and it's going to be y equals log base 4 of x. And so now we could build a table to graph that. But that's what we just did in this got it question over here. So I'm not going to build a table and start all over again. Okay, I'm going to copy this information and this graph over here. And now I'm going to graph this in pencil, because I don't really want to see, I don't want to keep the parent graph on here, but I need it so I know what the shift is going to do and where it's going to come from. So when I plot these, now here's what I've got. But now we've got to look at the other numbers in this problem. What does this minus 3 that's inside the parentheses do to my graph? That's going to shift it right 3. The plus 4 that comes after all of that is going to shift it up 4. So what we're going to do is we're going to take every point on this graph and shift it right 3 and up 4. So if I take this point and go 1, 2, 3 to the right and up 1, 2, 3, 4, that's where that point moves to. And now if I take this one and go 1, 2, 3 and up 1, 2, 3, 4, and my estimation is not great here, it's off a little bit, I think because I made my dots so big. And then this one is going to go 1, 2, 3, 1, 2, 3, 4. Yeah, I've distorted this a pretty good bit. I may need to go back and recount. And then this point, 1, 2, 3, 1, 2, 3, 4. At least one of my points is off here. Let me check this first one. 1, 2, 3, 1, 2, 3, 4. And it should actually be a little bit further to this side. But my asymptote is also going to move right 3 and up 4. 1, 2, 3, up 4. So this line right here is my new asymptote. So it will look kind of like this if I finish the whole graph. Okay, the entire graph, if I pick this whole, graph drawn in pencil, pick the whole thing up and go right 3 and up 4, it should give me this pink graph. And then I can go back in and erase the original, okay? I'm gonna leave it just so you can see it, but the graph we're looking for is this pink one. So now, for the guided question number 5, it just wants to know, how does the graph of each function compare to the graph of the parent function? They don't actually ask me to graph them this time, so I'm not going to graph them. We're just going to talk about them and describe what these translations do. Okay, so this 3 right here is going to make it go right 3, and the 4 makes it shift up 4. And that's all. If I know what the parent graph looks like, I move it right 3 and up 4, and that is this graph. So now for part B, the only stuff that's been added to it is this 5, and that is the A value that is out in front. And remember, when your A value is bigger than 1, it's going to stretch it up taller faster. So the way they write that is they say it is stretched by a factor of 5. All right, so that is the end of section 7.3. I hope the videos are helpful. Remember, if you have questions, let me know. Bring your notes in with you, and we can go from there.